If you get hold of two magnets and you push them, you can feel this pushing between them. What is it, the feeling between those two magnets?
What do you mean, what's the feeling between the two magnets?
There's something there, isn't there? I mean, the sensation is that there's something there when you push these two magnets together.
You're asking...
I must say, I think that's a perfectly reasonable question.
Of course it's a reason. It's an excellent question. Okay? But the problem that you're asking, you see, when you ask why something happens, how does a person answer why something happens?
Look at that, we conquered the mountain. Left it behind us. The strongest attractive force that inevitably draws us to the subject of physics is something basic and very human. The basic but never-ending curiosity of why. Why does the pen fall when I let it go? Why does the sun rise every morning? Why am I experiencing any of this at all? You see, in the last couple hundred years or so, we've been given this label, physics. We've been told that if it's answers to the mysteries of the universe that you seek, then study the subject where the great minds of the 19th and 20th centuries all worked together to turn mystery into mathematical framework. That's a nice slogan, but it's not really true. In this video, I want to explain something to you, beyond the advertisements and the theory, something deeper and darker about the very foundations of the subject of physics, so that you have the clearest understanding of what it really is and whether it's for you. You see, to understand truly what physics is as a subject, you have to understand a little bit about the structure of how science is actually done and the context behind it. In 1962, philosopher of science Thomas Kuhn published his most famous work titled The Structure of Scientific Revolutions. In it, he details how science progresses and some of the false assumptions you today probably still hold about the field over 60 years later after the publish of that book. You see, from the post-Enlightenment era, you've been fed the lie that science is a means to uncovering objective truth about the universe. That we can truly answer the question of why something happens analytically. This is a position you could take, called scientism in its extreme case, but you've been told for so long that this is a literal reality. That through explaining the process by which something happens, by explaining the how, you can truly understand the why. That saying red light has a wavelength of 650 nanometers truly explains the redness of your perception of it. But I hear you say, I don't care about these things. Red is red, leave it at that, leave the rest for the philosophers. And I agree with you, but there's another crucial idea that's even more important and practical to the actual daily workings of the physicist. You've probably heard of it. The now famous phrase, paradigm shift, describes a radical period in the development of a field, where the foundational ideas that support everything that stems from them break down and are built up again from the ground. This is what happened at the start of the 20th century. This is why people like Einstein, Schrödinger, de Broglie, Dirac, Heisenberg, and many more are still as famous today as they were back then. They were the pioneers of a new era of human knowledge, a paradigm shift. But we don't have figures like this today. Not anymore. Why? Because the very nature of the work today is different to its core. You have heard before that physics has been stuck since the early 1900s. The reason for this is not necessarily because the physics has gotten too complicated, or there's just too much to learn nowadays, or that we know everything there is to know. It's the simple reason that we're no longer shifting in our paradigm. The work you will do today as a physicist, and therefore a physics student, is within a given paradigm. This isn't necessarily an issue. This is how academia functions. This is how depth in a field develops. The same reason that before the turn of the 20th century, many thought that physics had been solved once and for all. But what it does mean for you as someone who wants to go into the field, as a student who is interested in the deep mysteries of the universe, this isn't the field that will satisfy that craving. That's the simple message of this video. If you have the natural human nature to understand why the world around you works the way it does, physics is no longer the field for you. Because those questions are not important to the physicist. The real physicist today spends their actual day solving extremely niche, very depth-oriented problems and publishing papers that a handful of people in existence will ever read or understand. Not necessarily because it's so complicated, but because it's so specific. This video, at its core, is a practical one. Speakers like Feynman or movies like Oppenheimer often paint a very romantic and grand feeling to this subject, and many people like yourself, like myself, become more attached to the ideas at the actual core of the subject more so than they are to the day-to-day workings of that subject. Understanding the fundamental nature of the way the smallest or biggest things in existence behave and interact with each other is one thing, a beautiful thing, but solving differential equations related to the oscillation of a random mechanical setup you will never encounter nor ever care for in the slightest is another. This video's simple message is to let you know that pursuing a degree or job in this field is far more of the latter than the former.